Before we start today, let's quickly revisit last class. We said cloud computing is really the story of the internet. Servers are only useful if the network connects us to them. We also talked about ISPs, from global tier 1 providers with undersea cables down to local tier 3 ISP that we pay at home. We also saw how internet moves the data using packet switching and routers, which choose the best path for each packet. That design gives us redundancy but also adds latency. We broke down the protocol stack from physical networks at the bottom up to application protocols like HTTP and email. And finally, we compared on prem networks with internet based cloud models. Where public cloud dominates because of its flexibility, today we'll zoom in on performance aspects like bandwidth, latency, and quality of service, then look at the business needs, wireless networks, cloud carriers, and adoption challenges. Bandwidth. Alright, this is the slide that says amount of data transferable per second. That's bandwidth. Think of it as the size of the pipe that carries your data. The bigger the pipe, the more water flows at once. Now, a bit of history here. Back in the 90s, most people had dial up connections. That was like sipping water through a coffee straw. You could send emails, but loading a single picture took forever. Then came broadband. Suddenly, the pipe widened, and video streaming became possible. YouTube and Netflix rode that wave. Today, we have fiber optic lines that pipe is massive. Bandwidth is also dependent on your ISP and the capacity of the links that you're using. That's why your internet feels faster at night when fewer people are online. There's less congestion on the pipe. And the companies use tricks like caching, compression, and prefetching to make it feel even faster. So the takeaway is every jump in the bandwidth has opened new doors for cloud. Without white pipes, cloud gaming, cloud conferencing, or real-time apps just wouldn't work. Let's talk about other half of the story, latency. Latency is the time it takes for the packet to travel from one point to another. Think of it like mailing a letter. Even if the post office can handle thousands of letters a day, how long it takes your letter to arrive is latency. It increases with each hop. Every router your data touches has a bit of delay. If traffic is heavy, packets might wait in line, just like cars at a traffic light, and that queue adds more delay. Why does this matter? Because cloud apps are sensitive to latency. Email doesn't care if it's delayed by 1 second, but in online gaming, a 1 second lag can mean losing a match. In financial trading, 1 second delay can cost us millions. So, latency is just as important as bandwidth. Bandwidth tells you how much data you can send, latency tells you how fast it can get there. Together, they define the experience, and when the networks can't keep up, that's when we start talking about quality of service. Most networks run on what we call a best effort basis. That means the internet will try to deliver your packets, but it doesn't make guarantees about timing or reliability. If there's congestion, some packets might get delayed, some might be even dropped. That's why sometimes your Zoom call freezes or your voice cuts out. The packets carrying your video or audio just didn't make it through in time. QoS is the attempt to fix this. Premium or private networks can prioritize certain traffics, like real time voice or emerging communication to make sure it gets through, but the public internet usually doesn't promise that. So, when we talk about the cloud, we are really building on a network that is doing its best, but it's not always perfect. Businesses that need more reliability often pay extra for guaranteed quality of service, and that ties directly to business applications. You might see this same application on the premium internet or premium hotspot on your phones as well. Most of us don't plug in with Ethernet cables anymore. We are either on Wi Fi or we are connecting over 4G or 5G networks. That makes cloud access easier, but it comes with limitations. Wireless often has higher latency and less bandwidth compared to the fiber. But here's the interesting part, engineering are finding ways around these limits. One example is mobile edge computing. Instead of sending your data across the country, They put small servers right at the cell tower, so your request doesn't have to travel as far. That cuts down latency. Another futuristic example is the vehicular edge computing. Cars can share computing resources with each other. Imagine cars exchanging real time traffic or safety data as they drive, powered by cloud connectivity. That's where the cloud meets mobility. So, yes, wireless has limitations, but technology is constantly pushing these boundaries. And that brings us to a different kind of player in the cloud world: cloud carriers. Cloud carriers are basically specialized ISPs. Their job is to connect the consumers, that's your business, or you, with the providers like AWS or Azure. They are the middlemen ensuring your data gets from point A to point B reliably. But here's the challenge: the path from a user to a cloud provider usually involves multiple ISPs. Each ISP controls its own network, and coordinating quality across all of them is really tough. One weak link can slow down everything. That's why some businesses work with multiple cloud carriers. It's more expensive, but it gives them redundancy and reliability. If one path fails, another can take over. For mission critical apps like hospitals or banks, that's extra cost is really worth it. But this also introduces adoption challenges, which is what we will be looking at next. Cloud adoption challenges. So, adopting cloud isn't just about picking which service that you need, like Amazon, Microsoft, or Google. It is also about making sure that the network connecting you to them can handle the load. Performance really depends on the ISPs along the way and their agreements with each other. In big cities with strong internet, cloud adoption is really smooth. In rural areas, it's harder. Sometimes on prem solutions still make more sense, so businesses have to strike a balance between three things: cost, reliability, and speed. Go too cheap and the performance suffers, go too fancy and costs skyrocket. The sweet spot depends on the business goals, and that leads us to the big picture, the summary of everything that we talked about. To wrap up, networking is the backbone of cloud computing. Without it, all those giant data centers would just sit in isolation. We have seen how ISPs, routers, and packet switching protocols, bandwidths, and latency all come together to make the cloud work. Every step in the internet's history, from dial up to broadband, or from broadband to fiber, and from fiber to 5G, has pushed the cloud to new heights. So when you think about the cloud, don't just picture the servers in the warehouses, picture the massive global network carrying billions of packets every second, keeping everything connected and running smoothly. That's the thing about cloud. It's it's just network beneath it all. And that's all for today's class, and I'll see you on Wednesday.